second part of Chapter 9 is on factoring. Again, be sure to print out this PowerPoint before you begin listening to the lesson so you'll be prepared. Once you've gotten that done, proceed to the next slide. A factor is the numbers you multiply together to make a product. Prime numbers are numbers that only have factors of 1 and itself. Examples would be 2, 7, 13, etc. Prime factorization are prime numbers that multiply together to make the original number. And the greatest common factor is the largest factor the numbers being compared have in common. Referring back to our previous slide, our greatest common factor, also known as your GCF, is the largest factor that the numbers being compared have in common. In this example, we are comparing 50 and 75. So we need to find the factors of these two numbers. Well, the factors of 50 would be 1 and 50, 1 times 50, 2 times 25, and 5 times 10. The factors of 75 are 1 and 75, 3 times 25, and 5 times 15. Well, if we're looking for the greatest common factor, we're looking for the number that they have in common that are both multiples. Our greatest common factor when comparing 50 and 75 is 25. Now let's practice finding the greatest common factor when we're given numbers and variables. First thing you'll want to do is compare the numbers. So we're going to take 6x cubed, and also going to compare 8xy. Well, the factors of 6 are 2 times 3. Factors of 8 are 2 times 4. Therefore, their greatest common factor numerically would be the 2. So we're going to go ahead and put that 2 up here where it says GCF. Then you need to look at what variables they have in common. Both of these numbers being compared have at least one x, so they need to be factored out. So your greatest common factor here is 2x. In our next example, we're comparing 12x to the fourth, 16x squared, and 8x. Our factors of 12 would be 1 and 12. 2 times 6, and 3 times 4. Our factors of 16 are 1 times 16, 2 times 8, and 4 times 4. Our factors of 8 are 1 times 8 and 2 times 4. So now that we have all of our factors listed, we need to find the greatest common factor, meaning the factor that all three numbers that we're comparing has in common. And you'll notice that our greatest common factor is 4. So for our GCF up top, we're going to put 4 for our numerical factor. And then also notice that each one of these terms has at least one x in common, so we have to factor out an x. So our greatest common factor is 4x. In this problem, if you remember back to chapter 2 when we first started learning how to solve equations, we talked about the distributive property. We have to distribute our 4 to the 3x and to the 6. 4 times 3x gives you 12x, and 4 times 6 gives you 24. Well, if you look at the left, your 4 and then the 3x plus 6, these are known as your factors, because that is what you multiplied together to get your product. Your factors can be monomials, binomials, trinomials, or polynomials. When you're trying to find your greatest common factor, you need to think about what number goes into both terms that can be taken out. Well, your factors of 6x and of 8 that we have in common are going to be 2. So what we want to do is divide 6x by 2 and divide 8 by 2. So 2 is our greatest common factor, and then after we've done the division we have 3x plus 4. So once we factored out a greatest common factor, you should write your final answer as 2 times 3x plus 4. Alright, in our second example, the greatest number that goes into both 10 and 15 is 5. However, in this example, we have variables. So if you look at your x's, each term has at least 3 x's. So I can also factor out an x cubed, and each term has at least 1 y. So I can factor out 1 y. So in this case, your greatest common factor is 5x cubed y. So we pull that on the outside of the parentheses, and then we do our division to find out what the leftover factor is. So 10 divided by 5 is 2. X to the 4th minus x to the 3rd just gives us x. Y squared minus y gives us y. And then if you notice in our second term, 15 divided by 5 is 3, but our x's cancel and our y's cancel. So our final answer is written 5x cubed y times the quantity 2xy plus 3. If you're not sure if you did this correctly, you can always distribute to check your work. In our first example, the greatest common factor is 4. So you're going to bring the 4 on the outside of the parenthesis. And do the division. On our second example, again, our greatest common factor is 4, but it's not just a 4. We also have variables that we have in common, so we can pull out 1c. So when we divide everything on the top by 4c, you get your leftover factors as c squared minus 2c plus 2. In our next example, the greatest common factor is 4n squared, because 4 will go into both 4 and 12. And we have at least 2 n's on each. So we have a leftover factor of 3n plus 1. Our next example, we have 5x cubed y. So that comes on the outside. And our leftover factor is 2xy minus 3. The standard form of a quadratic trinomial is ax squared plus bx plus c equals 0. You could also say that it equals y. You might see it written either way. The steps for factoring a trinomial. The first thing you'll want to do every time is try to factor out a greatest common factor. If you have one, you might not have one. Next, we're going to use our box method, but we're going to use the box method in reverse from how we've used it when we were learning about our polynomials. So, look through these steps and I will show you on our next slide how to apply them. Before we do an example, it's important that we go over some key notes. When your product is positive, both factors are either positive or both factors are negative. If both factors are positive or both are negative, you need to add them together and keep their common sign. If the factors have opposite signs, then you give the bigger factor the sign of your desired answer. Okay, so the first thing I'm going to do here is go ahead and draw my box, because mine didn't show up. Okay, so now we need to talk about how to fill the box. If you refer back to the previous two slides, you'll notice that your ax squared term needs to go in the first box. So our ax is going to be the x squared. So this goes in the first box, x squared. Our term that goes in the last box is your c. So 56 goes in the last box. Your next step is you're going to multiply the first box and your last box together and find the factors that add up to the middle term. So we're looking for our factors that add up to a positive 15x. So I've already listed the factors here for you, and we found that 7x plus 8x gives us 15x. So we need to add those into the boxes. It does not matter which box you put them in, as long as they go in the empty corner boxes. So now that we've filled our box, we need to factor out a greatest common factor for each row and for each column. So when we look at our greatest common factor for the first row, we have x squared and 7x. They both have an x in common, so we bring that out. On our second row, 8x and 56 both have a factor of 8 in common, so we bring that on the outside. Our first row, x squared and 8x, has an x in common. And our second column, 7x and 56, has a 7 in common. So what we need to do is bring our factors down into our parentheses. So we have x plus 7, because that was a positive 7, and x plus 8. And to double check your work here, you can always distribute, or just like we did with polynomials, you can multiply your factors on the outsides to fill the boxes and see if the numbers match up. If they do, you know you did it correctly. Okay, so again, to use the box method, we need to take our first term, put it in our first box. Our last term goes in the last box. Multiply them together and we get negative 32x squared. And we're looking for the factors that add up to negative 4. So when we look at our factors of negative 32 that add up to negative 4, we have 4x and negative 8x. Remember that the 8 has to have the negative because we want our answer to be a negative 4. And then just put them in the box. in the empty corners. Our greatest common factor on the top row is an x. The bottom row is a -8. Remember, since it's touching a negative box, your factor has to be negative. The top column is x, and your second column is 4. So our factors are x plus 4 and x minus 8. Our next example, again, fill the boxes. X squared is in the first box, 15 is in the last box. Multiply them together and you get 15x squared. And we're looking for our factors that add up to -8x. So we've got -3x and -5x. Remember, a negative times a negative gives us a positive. So fill your boxes. Our first row has a factor of x in common. The second row, -5. Your first column has an x in common, and your last column has a -3 in common. So your factors are x minus 3 and x minus 5. This example is a little bit different than what we've seen before, because this time we have a coefficient on our x squared. So we're going to need to still go use the box in the same way, but remember we have to multiply. So we have our 3x squared in our first box and a -4 in the last box. But when we multiply these together, we have -12x squared. And we're looking for the factors of -12x squared that add up to -1x. So our factors are going to be 3x and -4x. Fill in your box. Okay, so this time when we look at our factors for the top row, not only do they have an x in common, they also have a 3 in common. So we are factoring out a 3 and an x. Our bottom row has a -4 in common, so we factor that out. Our first column only has an x in common, and our last row has a 1 in common. Okay, that's the only factor that they have in common. So our factors are 3x minus 4 and x plus 1. All right, let's do another example where we have a coefficient on our x squared. So we've got to put 2x squared in the first box, -5 in the last box. Multiply those together and we get -10x squared. The factors of -10x squared that add up to -3x is going to be 2x and -5x. So fill in your box. Our first row's greatest common factor is a 2 and an x, so we've got to factor those out. Our bottom row has a -5 in common, so we have to factor out a -5. First column has an x, and the second column has a 1. So we have 2x minus 5 and x plus 1. All right, so let's do another example using our box method. Hopefully you guys are getting a little more comfortable with this method. X squared goes in our first box, negative 30 in our last. Multiply them together, we have negative 30x squared. And we're looking for the factors that add up to negative 13. So we have 2x and negative 15x. So put those in your box. Our first row has an x in common. Second row has a 2 in common. First column has an x in common, and our last column has a negative 15 in common. Remember, if it's touching a negative box, you have to factor out a negative. So we have x plus 2 and x minus 15. Now we're going to practice a word problem. The area of a rectangle is x squared minus 5x minus 14. Find its length and width. Well, we still have a trinomial here, and we've been factoring trinomials throughout this lesson. So what we're going to do is draw a box, and we're going to factor it using the box method, just as we've been doing. In our first box, put our x squared. In our last box goes our negative 14. Multiply them together, and you have negative 14x squared. And we are looking for the factors that add up to negative 5x. So we've got a negative 7x and a positive 2x. So fill in your box. Our first row has an x in common. The second row has a negative 7 in common. First column has an x. Our second column has a 2. Well, when we're looking at length and width, and we're specifically trying to find, we've been given the area and we're finding the length and width. The area is the product of the two factors. So the length and the width are the factors. So our length is x plus 2, and our width is x minus 7. Now let's talk about if we have a polynomial that has 4 terms. And when we're talking about these terms, we're looking at the terms that are sequential. So we have an x cubed, x squared, x, and then our constant. Okay? If you have exponents that go down in order and don't skip any numbers, then you can just fill in your box. So we have 2x cubed, 6x squared, 3x, and 9. So we just plug them into every empty box. As long as your first term is in the first box and your last term is in the last box. That's what we need to do, and then the others just fall in the corner. So our first row, we have a 2x squared in common because the first box has an x cubed, second has an x squared, so they have at least 2 x's, so we have to factor that out. Our second row has a 3 in common. The first column has just 1 x in common, and our second column has a 3 in common. So we need to x squared as our first factor plus 3, and our second factor is x plus 3. So let's do another practice problem. Our first term goes in the first box, then 5x cubed. Our last term is in the last box, and then our other middle terms just fill in the empty boxes. Now the nice thing is we don't have to multiply anything together, we just go straight to factoring out our greatest common factor. So we have a 5x squared in common on the first row, a 2 in common on the second row, an x in common on the first column, and a negative 5 in common on our second column. So our factors are 5x squared plus 2 and x minus 5. Okay, so we've got a practice problem that might look a little different than what we've been doing up to this point. This practice problem has two different variables. We have an a and a b. However, we're going to go about it the same way. You put your first term in the first box, our last term in the last box, and our middle two terms just fill in the empty corners. So 7b and negative 3a. In our first row, all that we have in common is the letter B. That's the only thing they have in common. Our second row, the only factor that they have in common is a negative 3. Then looking at our first column, the only factor in common is an A. In our second column, the only factor that they have in common is a 7. Well, A times B equals AB. B times 7 equals 7B. 3 times A equals 3A. And negative 3 times 7 is negative 21. So we know that these are the correct factors. So we've got A plus 7 and B minus 3 as our two factors. Okay, so we're going to show you how to factor polynomials using what's called grouping. When you're doing grouping, you need to split the equation or the expression in half. Okay, so just draw a line down the middle. Okay, we have two terms on the left and two terms on the right. So we need to find the greatest common factor and the leftover factor for each half. When we do this, the factors, the binomial factor on each side has to be the same. Okay, so let's see what we're talking about here. We have a greatest common factor for 5x to the fourth and 20x cubed of 5x cubed, and our leftover factor is an x plus 4. In our second half of the problem, our greatest common factor is 6, and our leftover factor is x plus 4. So let's make sure that we've done the first three steps correctly. We've split the problem in half. We have factored out our greatest common factors for each side, and our binomial leftover factors are exactly the same. Okay, Now all we have to do is put our greatest common factors inside of one set of parentheses, so 5x cubed plus 6, and then in our other parenthesis we have x plus 4, and those are the two factors of that polynomial. If you are still not sure with this method, you can always double check using the box method. Okay, so let's practice a few examples. We need to find the greatest common factor on the first half of the polynomial. Our greatest common factor is 4x squared, and our leftover factor here is going to be x minus 5. Remember, you can always distribute back to make sure you factored out correctly. In our second half, our greatest common factor is 3. When we factor out the 3, we are left over x minus 5. Distribute to double check. You'll notice that we do have the same binomial factors. So our final answer should be 4x squared plus 3 times x minus 5. In our second example, our greatest common factor is simply w squared. We're left with 2w plus 1, okay, because w squared times 1 gives you w squared. In our second portion of the problem, we have a negative 7 that factors out, and that leaves us with 2w plus 1. So again, our binomial factors are the same, so we've done that correctly. So in our first set of parentheses, we should have w squared minus 7, and our second should be 2w plus 1. The next section in Chapter 10 goes over difference of squares. It's very important that you memorize your perfect squares. That will help you during this section. And also notice that you can have perfect squares that are variables. Okay, so this is just a little helpful hint for you guys to use throughout the rest of this. When factoring differences of squares, you need to make sure that you always factor out a greatest common factor first, if you have one. The second step is you need to write down two sets of parentheses. You're going to give the first set of parentheses a plus sign, and the second set of parentheses gets a minus sign. Then you're going to take your square root of each term. Put the first square root at the beginning of each parenthesis, and then put the second term at the back of each parenthesis. Okay, so now that we've gone over kind of the steps, let's put it to numbers. Okay, so first thing we need to do is make sure that we have two perfect squares, which we do. So we're going to go ahead and write down our two parentheses. That's step one. First one gets a plus sign, second one gets a minus sign. And then we take the factors of each term. Well, the square root of x squared is x, because x times x equals x squared. The square root of 16 is 4. because 4 times 4 is 16. So if you FOIL this out or put it in the box, you'll get x squared minus 16. That's how you double check your work. However, the factors are simply x plus 4 and x minus 4. On our next example, if you look to the right, we need to factor out our greatest common factor. The greatest common factor between 3x cubed and negative 27x is 3x. Our leftover factor is going to be x squared minus 9. Okay? For now, we're going to ignore the 3x squared. We've got to focus in on our x squared minus 9. So 3x squared, or 3x, excuse me, just comes straight down. Then draw your two parentheses. Give the first one a plus sign, second one a minus sign. The square root of x squared is simply x. And the square root of 9 is 3. And that is your final answer as far as the factor is concerned. On our third example, we can't factor out a greatest common factor because it doesn't have one. So we're going to start with our two parentheses. Now, first one gets a plus sign, second one gets a minus sign. However, this time we have a coefficient in front of x squared. So our coefficient, square root of 9, is 3. But it was also paired with an x, so we have to keep the x with it because the square root of x squared again is x. If we do it to one, we have to do it to the other. So 3x goes in the front of both sets of parentheses. The square root of 4 is 2. So we should have 3x plus 2 and 3x minus 2. And our last example, write down our parentheses. Give the first one a plus, the second a minus. And the square root of x to the fourth power is x squared. So x squared goes at the beginning of both of those. And the square root of 64 is 8. So you put that at the end. Okay, so now we need to talk about the steps for dividing a polynomial by a binomial. The first thing you need to do is make sure that you have a polynomial that has no missing exponents. If you're missing a term with an exponent, you need to put one there and multiply it by 0. Second step, we need to complete long division by putting the binomial on the outside of the division bar, and the polynomial goes under the division symbol. You need to think, what number can you multiply the first term in the binomial by to equal the first term in the polynomial? And you're going to write that number above the second term in the polynomial and multiply through. And this will make a little more sense when we start our examples. And you're going to repeat the process until you run out of terms. So now let's do an example to help make this a little more logical. Okay, so we have to put our binomial on the outside of our division bar, and our trinomial goes underneath. So we have 2b squared minus b minus 3. Notice that our exponents go down in order. We have 2, 1, 0. Now we need to think about, what number do I multiply my first term in the binomial to get my first term in my trinomial? Well, b times what gives me 2b squared. 2b. Okay, and that should be going over the second term in your trinomial. So 2b times b gives me 2b squared. However, I also need to multiply my 2b times 1. So that's a plus 2b. Now we've got to remember back a long time ago to what we do from here. We need to subtract. Okay? I'm putting that in parentheses because not only am I saying 2b squared minus 2b squared gives me 0, I'm also saying negative b minus 2b gives me negative 3b. Now I need to think, bring down my minus 3, okay? And I need to think, what can I multiply b by that gives me negative 3b? Well, that's negative 3. So negative 3 times b is negative 3b. Negative 3 times 1 is negative 3. We need to subtract. Negative 3b minus negative 3b cancels out. Negative 3 minus negative 3 cancels out, so we do not have a remainder here. And therefore, our factor is 2b minus 3. That's our final answer. Okay, so let's do another example of dividing a polynomial by a binomial. What times b gives you 2b squared? Well, that would be 2b. So that goes above your second term in the trinomial. 2b times b gives you 2b squared. 2b times 1 gives you 2b. We're going to subtract these. Our 2b squareds cancel out. Negative 1b minus 2b gives us negative 3b. Bring down the minus 3. And then you have minus 3. Negative 3 times b is negative 3b. Negative 3 times 1 is negative 3. Subtract. The negative 3b's cancel because a negative times a negative is a positive. And the negative 3's cancel because a negative times a negative is a positive. You have no remainder, so your factors are b plus 1 and 2b minus 3. And those multiply together to give you your trinomial, if you want to check your work. On our last example, you'll notice that in this example, we have a term with a 0 in front of it. The original problem looked like x to the 4th plus, that should be x squared plus x minus 3. However, we had to put a 0x cubed to make sure that we had our exponents in sequence. So that's why I have a 0x cubed there. So x times x cubed gives us x to the 4th, and then minus x cubed. We're going to subtract, and our x to the 4th cancels, and 0 minus x negative 1x is x cubed. Bring down our x squared. X times x squared gives us an x cubed. We're going to subtract these. And that should be a minus here. Because x squared times negative 1 is negative x squared. So our x cubes cancel out, and 1x squared minus negative x squared gives us 2x squared. We need to bring down our x. And 2x times x gives us 2x squared.
If you are driving a red Toyota with the license plate X,
negative 1 gives us negative
3874, please come to the main office. If you are driving a red Toyota license plate XKP 3874, please come to the main office.
Minus negative 2 gives us 3x. We bring down our negative 3. I apologize for the announcement in the middle of our explanation. And we are going to multiply 3 times x, which gives us 3x. 3 times negative 1 is negative 3. When we subtract these, everything cancels. And so this is your final answer. Okay, so here's a real world problem when you might divide a polynomial by a binomial. We've been given the area and the width, so we are solving this equation for length. In order to solve that with our formula, we need to divide both sides by w, and you see that length equals the area divided by the width. Okay, so we need to put our binomial on the outside of the division bar. So 2b minus 1 divided by 4b cubed. And if you remember back to previous slides, we have to have our exponents in descending order. So we have a b cubed, but we're missing a b squared. So we need to put a placeholder in there. So we're going to multiply b squared by 0 just to hold the place, and then continue on writing the problem. Okay, so what times 2b gives me 4b cubed? Well, that would be 2b squared. So we have 4b cubed, and then 2b squared times negative 1 is minus 2b squared. We are going to subtract. Our 4b cubes cancel. 0 minus negative 2b squared gives me a positive 2b squared. Bring down my 5b. Well, what times 2b gives me 2b squared? that would just be a b, a 1b. So 2b times b is 2b squared, and b times negative 1 is minus b. So we're going to subtract again. My 2b squareds cancel. 5 minus negative 1b is the same thing as saying 5 plus 1. So we have 6b. Bring down my negative 3. And 2b times 3 gives me 2b, or gives me 6b. 3 times negative 1 is negative 3. And when I subtract, both the 6b and the negative 3's cancel out. So your length equals 2b squared plus b plus 3.